me mention it again. In the RS meetings, I am presenting to you a new estimating principle, assembly. I recommend read the beginning of that section or chapter, I don't know how, before you jump into the detail. I think several students stayed back, I think a few weeks back, and it's overwhelming. It is very overwhelming when you jump straight to the detail. I recommend understand the introduction, table of contents, and the how-to. Do not move forward from the how-to section until you say, I got it. Say, I know what's going on. I got it. It's good, very informative. Or stay after class and we'll do it together. So, part 1, thermal moisture protection, division 7. This is the template sheet that I'm asking you to use for this week's exercise. My observation, what I've learned before from previous classes, is that this template is friendlier than the previous templates. Okay, friendlier. You'll see, and I'll show a couple examples here. We're going to go through thermal moisture protection, quantity takeoffs of waterproofing, insulation, and roofing, felt and shingles. So for an hour and 40 minutes, I was going through page after page after page of all this content, a lot of information sharing with you. For this activity, for this exercise, we're focusing on waterproofing. Unit measures square foot to then calculate gallons. Insulation, area to calculate rolls. Roofing, felt to get square foot to rolls. And then shingles, area square foot to get squares. So these are the key unit measures and scopes we're talking about for thermal moisture protection. Start with, let's kind of understand more of those various scopes, and then I'm going to jump into an example in the activity. Thermal moisture protection, waterproofing. Waterproofing is applied on the wall system because after the backfill, water can enter in. We want to prevent the water from entering into the building. So we waterproof. Waterproof is displayed here in the template. Here's our category. This is the waterproofing. It's typically placed on walls. Unit measure is gallons, converted from area, so we understand length. Width, to get area, we have a coverage, because how many gallons we want to order, because the gallons is applied on the area, so what's our coverage? So how much coverage? That will be provided for you. Questions on this? Waterproofing. Now we move into insulation. Rolls. This is the blanket or roll insulation placed in between wood frame systems. This is the spreadsheet. We have insulation, we have our floors, we may have our walls, we may have our roof systems. So we have a floor, its area to calculate square foot. Then we have our roof, our joist spacing. And then with that, we have our 2 calculation methods. Our 2 calculation methods is using this table. This table is in the textbook. It's also going to be on several slides here. So calculation method number 1 is going to say, I have so many rolls calculated from our joist, our spacing. And then the other one is the effective coverage that is of that same area. And I'm going to show an example of how that's calculated out. By now you may be looking at this template and say, what's all these ones populated speckled? These are placeholders for you to populate. This is just a placeholder saying hey, a number needs to go here. Then as we move on to our roofing system, 2 major components, the felt, this goes on top of the sheathing, and then your shingles. The key part of roofing is the overlap. That one purpose of a roof is to shed the water, resist penetrations. By doing so, we do very conservative overlap. So if we overlap, that means we're placing a lot more material on the building because we have this overlap, or it's almost like we're only using 1/2 of the true area of the material. This is the template of understanding roof, felt, and then after that we'll get to our shingles. Notice here, the key items here is first determine how much is the roof area itself, because if it's a slope condition, using the plan view, it's going to give us some measurements, but we need to understand that factor. And I think that factor is bringing it up from back to chapter 14. If we know the pitch or the slope, there is a factor, and that factor is placed right here. So if I have a run, which is the horizontal distance, 14 feet, times the factor, 1.03, we get the true total. This template is specifically set up to say, well, here's my run, but then we add the projection, the amount beyond the exterior wall of that same distance times that same factor to get a total length. So the objective here is to understand what's my true surface area of the roof to calculate felt and then shingles using the factor. Questions? Then after we got our felt down, now we have our shingles. Our shingles are going to say, well, what's the area of our shingles? And then our starter course, because the redundancy of the systems, we want to make sure we have that starter course. And then after that, we do our shingles with our exposed or overlapping area. We have this other category down here, the ridge, because after you bring up your shingles, you have that top ridge. You need shingles along that top using these data inputs. Questions? Key item here is really understanding our insulation and our factors to understand true lengths. It's using these tables. It's grabbing the tables to understand those factors, to enter them in, to then calculate our delivered unit measure, or our quantity takeoff. So let's practice this. Let's go ahead. So I introduced the template. I showed a couple examples of the scope. Now we're going to apply it, our famous garage. Our garage keeps coming back up. So we have our 24 by 30 foot garage, single door with a passage door in the back. Here's our framing plan for our roof and our floor plan and one of the elevations. Start off waterproofing. Let's pretend that this garage is robust and we have a 5 foot high wall holding up our garage, and so we need to waterproof our assumed 5 foot high wall. So we have our north wall, south wall, west wall, east wall, grabbing those key dimensions. 30 feet by 24 feet. So we got our north wall, south wall, west wall, east wall. This is all the wall in our foundation. Key dimensions. How high is our wall? Where we're assuming 5 foot high. Length, height, area, total area. And then we have our coverage. Our assumed coverage is we're saying 1 gallon can apply 65 square feet of waterproofing. So 1 gallon of this stuff applied on the wall. How much can you put on the wall from that 1 gallon? Only 65. So gallons per square foot is our coverage. So the area divided by coverage rate is 8.3. When's the last time you went to the store and bought a 0.3 gallon? So we round up to 9 gallons. Yes?
Are we assuming that the garage door is not there?
This is the waterproofing of the foundation wall.
Foundation.
Below grade.
Okay.
Below grade. It's our robust garage. We need a 5-foot wall for our garage.
So it's a cute garage.
Yeah, wall. Yeah, so this is all underground waterproofing.
I got you.
Questions, other questions? Moving on, let's do some insulation on the floor. This robust garage, we have our floor framing. Our garage floor area is 30 feet by 24. We assume a joist spacing of 16 inch on center. 16 inch on center. So we have an area from these two key inputs. And here is our factor. Let me see if I got the two. I'm bringing in the factor here. Here's our floor plan. 30 feet by 24. 30 feet by 24. Our joist spacing is 16 inches, so our converting our square foot of linear foot of insulation is using this figure, 15.7. So if we have spacing of 16 inch on center, that gives us an insulation weight. Determine the linear feet of insulation, because linear feet of insulation is, we use a factor of 0.75. And then we also assume our rolls, because our end game, the finish line of our insulation is how many rolls. And each roll has so many linear feet. We're assuming that each roll has 100 linear feet. If I have this much linear feet from that factor, from this area, using these key items, I need 5.4 rolls. We round up to 6. That's method one. How much linear feet off of the spacing of our studs? Calculation number two is they call it effective coverage. Well, the effective coverage is our roll length times our spacing. We have a 100-foot assumed roll length. Our effective is 1.3. You say, how do I get 1.3? Well, the width, the spacing on times our roll length. The width is 16 inches. 16 inches is 1'4". Converting imperial to decimal feet is 1.3. So the length is 1.3 because it's your effective coverage area. 100, 1.3 gives you that how many square feet per roll. Round it down and it gets you 5.46. You'll see it's a match. This is a good way to do two different approaches, so these numbers can reasonably come in close. If one comes in 12, the other one 4, something went wrong. Either a factor, conversion, or a takeoff. Two approaches for insulation. Questions on this? Yes, Mike? Yes. Yes, do both. Yes. Key item is the assumptions. How long is a roll? I think the questions that I'm prompting you in the exercise, it says roll is assumed 100 weight distance. I'd recommend go to Home Depot or Lowe's, go down the insulation, look at those rolls, see what those rolls are made up of. How long are they really?
I'm just a little confused because earlier you said that the waterproofing for the foundation was like water.
Is what?
For the foundation was water that I used to waterproof.
This one here.
On the previous slide you said like
Fair,
gallons.
fair comment. Yeah, fair comment. I shared in all those previous slides, I had parging for damp proofing, then waterproofing using a barrier. For this example, I'm using a liquid applied waterproof. So the liquid approved, here it is. So for this waterproofing example, it is a gallon, it's a bucket. You stick in a roller and you just apply it on the wall.
It can also be water that you use it for body.
If it's damp proofing, where you use mortar for parging, that would be cubic foot unit measure. Yeah, but you are correct. But for here, for this activity, and for the exercise, I'm looking at waterproof using a liquid material. So it's gallons. Okay, thank you. Thank you for clarifying that. You're exactly right. There was like 4 slides of all these different things. For here, it's this week, it's gallon. Go ahead, Nick. There's our rules. There's our table. Now we're going to do our roof insulation. We just did our floor framing. Okay. Now here's our roof. All right, roof is on a pitch or a slope, so we need to understand the true length or area of the roof. Here's our floor plan. Here's the framing. We understand a projection. We understand a lookout, meaning the roof is bigger than the actual structure itself. So we understand, well, what's that run and what's the factor? Well, it's 12 foot, which is going to be from ridge to the wall. Half of 24 is 12, plus the projection of 2 feet. Both of them applied with a factor of 1.6, 1.06, 1.06. Well, it must be the 1.055. So it's a 4 and 12, giving us the true length. Notice here, now the objective here for roofing is you want the true area. We're not getting into the, well, it's only offered in 16-foot length for rafters. That's division 6. We're division 7, we want the true area. So we carry this number forward. So the roof area itself is going to be, for the north side, it's going to be the true length of 34 feet, not the wall to wall. It's from lookout, edge of lookout to edge of lookout, 34 feet times that number, 14.8. So this is where we're calculating that number and we're using that number. This is not where we have that discretionary length anymore. Previous exercise. So we have a total roof area, don't forget the other side. And then from that, our rafter spacing, because we're insulating it, is at 6, what did we say? 24 inch on center. So we use that factor, 24 to understand linear foot. And then we convert to number of rolls, 754. Now, I purposely manipulated this spreadsheet for a reason. We just did the flooring of how many rolls of insulation? 6-ish. Our roof is coming up at 754 rolls. This is where that spidey sense comes in to say, boy, that number looks wrong. And it is wrong, because here we did not properly put in the conversion. We left the placeholder. So this is my comment to you. As you go through this, if you methodically do a floor, and you get 6 rolls, then you do the roof and you have over 750, that should be the indicator to say, hey, something's not right. Because that calculation needs to be the conversion that we use in the table. I don't know if I have the right answer here. Do I have the right answer here? I don't. I don't have it. So make sure here that conversion of here is how many feet does each roll have of insulation. So when we come to here, when we convert linear feet to rolls, each roll has, we'll just assume 100 feet. If it's 100 feet, we're coming to like 7.5 rolls. You see how it brings it back down. You're just bringing it back in. So let's just be mindful. I don't know if my example here was effective or not, but this is it. Just be mindful as you go through these things. Make sure these placeholders, you're actually putting in the needed number as you go row by row, going down. Questions? Now we're doing our roof. When we do our roof, what's the template is asking you to again put in your inputs of what's my run, what's my factor, what's my projection, what's my factor to get it. Some students in the past said, you know what? I'm just gonna say, I did all that work in my insulation. I'm just gonna grab that number and bring it down and reuse it. If you do that, that's great, but say that. Just say that, say carrying number used for insulation. So I got my drawings up here. My run plus the factor, my projection plus the factor gives me that true length. This gives me the true area, same quantity of roof area. So my amount of felt is, you say, well, how much square foot is per roll? Well, I have a 100-foot roll at 3 foot wide. That means each roll applies 300 square feet. However, because I have this overlap, my overlap, what's my exposure, which is my width of 3 feet, minus the lap of 1 inch, is 1 foot. So my true effective area is converted to inches. Now when I use that inches, my roll width converted the same inches, you can see what's my effective is 200 feet per roll, meaning I need 6 rolls, or it's 5.2. Now you see, as I went through row by row by row, you're gonna see all these are yellow. They're gonna start populating as you do these key data inputs. The key are these 4 numbers. What's my roll? 100 foot long, 3 foot wide. It will be a presented number assumption for you to include. What's my lap or my effective? It will be provided. So entering these items, provide this, will get you a number of rolls. Questions? I would recommend another sense is that the true effective area should be a number much less than the provided coverage a roll will provide it without the overlap. So one number should be greater than the other. Then I'm on my shingles. Let's bring my drawings up with this. Again, it's asking, well, here's my roof shingles. It's now providing, you'll see this is yellow. So when you populate above the spreadsheet, it's going to bring that number down. So the template is taking advantage of work done prior. You say, what's my true length, including the overhang, my true area. Then my starter course is just asking, well, what's my eve length, 2 sides, exposed shingle, entering these numbers in feet, and your factor is a number of 2 because it's 2 sides, number of square foot, and then you add a waste factor for this element, gives you the number of squares of shingles needed. 1,084.6 square feet or 10.8 squares. Once you get those primary data points, area, spacing, coverage, you'll see the template will start populating it out. I just ask pause at each section to say, does this number look right? Like that example I gave you, I didn't put in the how many linear feet of insulation is for each roll, 100. It was just 1, and it gave this very large number result. So pace yourself as you go through to say, yeah, these numbers feel right. Questions? Questions? That's thermal moisture protection. Let's move on to RSME.